Welcome back to Claw and Fossil. Today's episode is not casual. We're diving into the giraffe. A species, if analyzed as a system, reads like an evolutionary black site dossier. Every organ, every bone, every neurological pathway has been optimized to operate at the edge of physical possibility. If giraffes were humans, they'd be classified as mobile tactical weapons. And yet they walk the savannah like everything is normal. Let's break this down. So, the great overview here. Giraffes are deceptively non threatening until you examine the architecture of their bodies. Height alone is a survival multiplier. Standing up to 6 meters tall, they operate above nearly every predator's field of vision, but height is just the framework. It's the biomechanical chassis for every other system. The threat assessment standpoint, a giraffe is vertically optimized, sensorily aware, and structurally lethal. Their long necks are not actually ornamental, they are integrated surveillance towers capable of both reconnaissance and physical combat. So, their cardiovascular intelligence. The heart is the first line of system stability. Adult giraffes generate systolic pressures up to 300 mmHg, necessarily to pump blood to the brain across a 2-meter vertical span. Their ventricles are thickened to 2.5 centimeters with the contractile fibers arranged for maximal stroke efficiency. Peripheral arteries in the legs contain sphincters to prevent edema. Cerebral arteries feature a reedy, measurable network that dissipates sudden pressure surges when lowering the head to drink. These systems operate continuously without fail, like a hydraulic pressure network engineered for extreme gravity. The cervical and musculoskeletal engineering. 7 cervical vertebrae, identical to the number of humans, in humans at least, are paired with ligamentous spring systems, nuchal ligaments that absorb kinetic energy from combat to rapid neck motion. Male giraffes engage in necking, swinging 700 to 800 kilograms of cervical mass with the force exceeding 7,000 newtons. The skeletal system tolerates these impacts without structural failure. Muscles, tendons, and vertebrae work as coordinated stress dissipation matrix, a natural shock absorption system far exceeding what terrestrial engineering could replicate. And let's get on to the neural sensory operations. Giraffes maintain precise perception across extreme vertical spans. Vestibular, visual, and somatosensory inputs are integrated to coordinate locomotion, feeding, and social engagement. The brain cellulates or calculates multi-limb kinematics while processing visual threats up to 1 kilometer away. Neural latency is minimized, so one misstep could be fatal, and evolution has eliminated it. From a systems perspective, giraffes operate as if equipped with real time computational control network handling gravitational torque, head stabilization, and predators detection simultaneously. So let's talk about their foraging and prehensile systems now. Their prehensile tongue, up to 50 centimeters, is melanized for UV protection, coated in keratinized epithelium or something like that, I don't know, is effectively a multi-tool manipulator capable of precise defoliation while avoiding acacia thorns. The lips, tongue, and jaw muscles coordinate with millimeter accuracy. Their feeding mechanics are surgically precise, optimized for over millions of years to maximize caloric intake while minimizing exposure to predation and thorn puncture injury. And here's their locomotion and combat evaluation from my research. Locomotion combines speed, agility, and structural optimization. Giraffes can spread up to 60 kilometers or for short bursts, their limbs act as spring loaded levers. Tendons store elastic energy, and the cervical mass is dynamically counterbalanced. Combat evaluation shows neck delivers lethal force without self injury, a testament to both skeletal reinforcement and ligamentous energy absorption. The males are virtually untouchable by predators when healthy due to this combined offensive and defensive optimization. The reproduction and postnatal deployment is that overall the gestation lasts 15 months, producing calves capable of standing within hours. Neonates are immediately operational for survival, possessing fully functional cardiovascular, musculoskeletal, and neurological systems. Rapid postnatal competence is stressed. It is, at this point, it's strategically essential. As predation risk is extremely high, evolutionary prioritization ensures that newborns are field deployable combatants from birth, maximizing herd survival rates. So, social, parasite, and environmental integration is that giraffes exist in loosely hierarchical herds. Parasite load is managed through grooming, avian mutualisms, and spatial distribution. Thermoregulation relies on cuteness, vasomotor adjustments, conductive cooling, and behavioral shading. Each giraffe balances physiological, environmental, and social vectors simultaneously, a form of multi-layered operational management rarely seen outside engineered systems. And their strategic Strategic evolutionary conclusion. When you integrate all these systems, the giraffe is no longer just an animal. It is a vertically optimized biomechanical entity. Every organ, limb, and neural circuit operates at maximum efficiency, coordinated in real time for survival, competition, and reproduction. Predators, environmental hazards, and conspecifics are accounted for, even at all times, basically. Evolution has essentially programmed an organism capable of both intelligence level risk assessment and combat readiness, all while maintaining and remaining graceful and efficient. To classify giraffes as simply tall mammals is to ignore a system level marvel of evolutionary engineering. They are mobile surveillance platforms, cardiovascular supercomputers, precision foraging units, and unintentional apex combatants. Observing a giraffe is not merely witnessing life, it is basically the physical embodiment of evolutionary problem solving at its absolute limit. That concludes this dossier. In future episodes, we may conduct similar full spectrum intelligence analyses on other extreme organisms like elephants, mantis shrimp, cassowaries, each with systems that defy expectations and push the boundaries for survival engineering. So, this has been Claw and Fossil. Treat the world with curiosity and understand that evolution is capable of far more than we actually imagine. So, thanks for tuning in and subscribe.